Why hello there, and welcome back to Tabletop Ferox. So, I recently received a Tumblr ask asking if and how you can roll a d216 with d6, which of course I answered thoroughly, as I am wont to do. However, it also occurred to me that I could answer it even more thoroughly in video format, which I am doing right now. And the simplest answer to that question is that yes, as 6 times 6 times 6 is 216, you can in fact roll a d216 with 3d6 and the formula 1d6 plus 1d6 minus 1 times 6 plus 1d6 minus 1 times 36. So if you rolled a 4, 3, and 6, the result would be 196. And if you rolled a 5, 1, and 1, the result would just be 5. So if you just wanted to know the how of rolling a d216, that's how. Of course, the how isn't nearly as interesting as the why, which is what I will be discussing in the rest of this video. And to explain that why, I think that I'm going to start with the simplest and most widely known version of this concept: binary. Which I believe I already covered in my video on base 36 dice, but that was all the way back in 2018, so I guess I might as well just cover it again. In binary, digits have one of two states, either 0 or 1, or off and on, because when taken in a sequence, you can read those values differently to express numbers other than 0 and 1. So, for example, if we had 4 binary digits, which for the purpose of this conversation you can basically think of as 4d2, the first would have a value of 0 or 1. But then for the second digit, we multiply those values by the total possible outcomes of all preceding digits. In this case, one preceding binary digit, so 2 times 0 is 0, and 2 times 1 is 2. Then for the third digit, we must once again multiply those values by the total number of outcomes of all preceding digits. And this time we have 2 binary digits preceding, so 2 times 2 is 4. And then for the fourth digit, 2 times 2 times 2 is 8. So now we have one digit that can be read 0 or 1, one digit that can be read 0 or 2, one digit that can be read 0 or 4, and one digit that can be read 0 or 8. For a total of 2 times 2 times 2 times 2 is 16 possible outcomes. And yes, there is a much easier way I could have explained that, but I am not explaining binary. I am using binary as an example to explain a concept that I will expand upon later, so I am specifically explaining this in a way that will still be applicable to that later explanation. But for now, how do we get 16 contiguous values out of these 4 binary digits? Well, it's actually quite simple. We just add together the expressed value of all digits. The trick is how we manipulate those states to give the values that we want. So, starting with all digits in the 0 state, the total is 0. Then to add 1 to that value, we increment the first digit from 0 to 1. But then, if we wanted to add 1 again, we cannot increment that first digit further because it only has 2 states, 0 and 1. So the first digit loops back to 0, and that plus 1 carries over into the second digit, which is now set to the 2 state. Then, with the first digit back in the 0 state, we can once again add 1 to that, for 1 plus 2 equals 3. But then if we want to add another 1, once again, incrementing the first digit sets it back to 0 and carries over to the second digit, which also sets back to 0 and carries over to the third, which is 4. And then that process continues until all digits reach their on state, and we have 1 plus 2 plus 4 plus 8 equals 15, which, taking 0 into account, is in fact 16 contiguous results. So if you had a need and desire to do so, you could basically roll a d16 by flipping a coin 4 times. But now that that is more or less explained, let's return to our d216 formula and examine it a little more closely. So we start with 3d6, then subtract 1 from the second and third die. And I'm also going to subtract 1 from the first die just for the sake of explanation, and that will not affect the actual math, and I will demonstrate that later. And now hopefully you've noticed that it's basically the same, except that instead of binary digits with 2 states, we have senary digits with 6 states. Then the next step in the formula, we must multiply the values on the second die by 6, which, as explained previously, is the number of total outcomes of the first die. So with those adjustments, the second die now returns results of 0, 6, 12, 18, 24, and 30. Then for the third die, once again, we multiply those values by the number of outcomes of all the previous dice, and 6 times 6 is 36. So 0, 36, 72, 108, 144, and 180. Giving us one die that counts up in increments of 1, a second counting in increments of 6, and a third counting in increments of 36. And just like binary, each die will always be in one of those 6 states, providing a range from 0 when they are all in the first state to 215 when they are all in the 6th state. And they increment the same, just with 4 additional steps. So starting from 0, we go 1, 2, 3, 4, 5. Then because we cannot increment the first digit further, set it back to 0 and increment the next die to its second state, which is 6. Then 7, 8, 9, 10, 11, and back to 0 and increment the second die to 12. And then, of course, once we reach 35, die 1 and 2 both get set back to 0, and the third die is incremented to 36. And of course, as I said, if we put that first die back to 1 through 6 instead of 0 through 5, it still works exactly the same. It just goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and so on and so on. The math works exactly the same, the only thing being changed is how we're reading it. And you may have already realized that, yeah, this is the same process as rolling a d100. You have one die with a set of values from 0 to 9, and a second die with values from 0 to 90 in increments of 10. 1d10 minus 1 plus 1d10 minus 1 times 10, and then usually read a result of 0 as 100. Once again, the math here is exactly the same. It's just that the results are much easier to read with d10s because we use a base 10 number system. Or at least I do, and I assume you do, but honestly, I don't know your life. And then using this not exactly practical technique, you can roll a d any number equal to x times y times z, provided that x, y, z, etc. are all numbers that can be rolled, using the formula 1dx plus 1dy minus 1 times x plus 1dz minus 1 times x times y, and so on and so on. And so far, all the examples I've looked at here have been situations where the dice are all the same, but I said I would explain it in a way that could not use the simple exponent calculation, so let's look at one where they are not the same, and say that we want to roll a d72 using a d6, d4, and d3. So x equals 6, y equals 4, and z equals 3. So then just like before, we subtract 1 from all the dice after the first, then multiply the values on the second die, the d4, by the number of outcomes preceding it, which is the 6 outcomes of the d6, so 0, 6, 12, and 18. and 6 plus 18 equals 24, as does 6 times 4, so these two dice by themselves are also just a d24. Then we multiply the values on the d3 by the total number of outcomes preceding it, which, as I just said, is 24, 6 times 4. So 0, 24, and 48. Then returning to our formula, we see that the first die is 1d6, the second is 1d4 minus 1 times 6, the value of the first die, and the third is 1d3 minus 1 times 24, the product of the values of all preceding dice. And then from there, you could add a 4th, 5th, 6th die ad infinitum. Of course, the more dice you add, the less practical it becomes, and let's be honest here, even with 2 dice, it's not really that practical of a process to begin with, unless you literally write those adjusted values on the dice. But, if you desperately need to roll those x times y or x times y times z values, now you know how to and why it works. And if you want to know even more about the exciting world of dice math, check out The Goblin Guide to Advanced Dice Rolling, a book I wrote on that specific topic. And thank you for watching. If you enjoy my sassy wit, art, and saucy euphemisms, you can follow me on Blue Sky and Tumblr, or catch me streaming on Twitch occasionally, just, not very often. Also, there is a Discord now because people kept asking me if there was a Discord, and now there is. Links to all of that in the description. And as always, an extra special thanks to my Fightin' Flail Snails: Broken Unicorn, D-Stex, Diablade, Frankly Fabulous Festering Flesh, Just Dave, Nikolai Snowtail, Puggo, Randy Mulholland, Ramogus, Renee D, Stephen Hafner, Stephen Kramer, Tila Glar, Toshiro Okuro, and Tyro the Fox. If you want to be cool like them, check out my Patreon or channel memberships. 2 different things that provide similar but distinct benefits because they are on different platforms that only offer different benefits. But if you don't want to do that, that's cool too. You can still hit all the lovely buttons, like, subscribe, smash the buttons, whatever they are. Or, maybe click on one of these other videos that has mysteriously manifested from the ethers, which I am sure are lovely videos that you will also enjoy. And I will see you next time.